Alright guys, how's it going and welcome back to another satisfactory video. Today we're going to do something a little bit differently because a couple of days ago a new subscriber called Aaron Henderson left a comment on the merged output overflow manifold system video saying that it had helped him wrap his brain around effectively routing or efficiently routing a basic factory. The issue he's having now is scaling it up to more advanced items with even more inconvenient requirements. And he was asking if I had any plans to make another video on the more advanced stuff. So I replied back to him asking what kind of things he had in mind. Was it assemblers, manufacturers, and so on? And he replied back saying, yes, I'm struggling with the space elevator stuff mostly. They require such advanced stuff, but like 4 per minute, and my issue is getting the whole system to run effectively. Like my smart plate factory is just a nightmare because I need so many screws for rotors and reinforced iron plates. I'm struggling to make enough and I'm overproducing iron plates and rods. I guess what I'm asking for is help with finding the balance for items that require a ton of one thing and very little of another. Possibly you could use the smart plates as an example if you're going to make a video about it. And then goes on to say thanks for trying to help, he really appreciates it. You're more than welcome, Aaron. I'm more than happy to help. I find this is actually a brilliant break from the norm, and it helps me address the stuff that people actually want to see in a way. It helps solve the problems. That's the whole point of the tutorial series I've been doing. It's kind of teach the principles of, if you will, of the game, and then people can use those as little building blocks, and you can build from there and build it into a far more advanced and complicated thing. But I know exactly what you're saying, where you have a ton of one thing and not enough of another thing, and how do you balance it? And it's a nightmare. So what I've gone and done is I've already asked him some questions about how he lays out his factory. So I know he has overclocking unlocked, which is something we're going to need because of actually underclocking in this case. And secondly, what kind of system does he use? Is he doing a main bus or is he going OR straight to final product? And he's replied back saying he does have overclocking unlocked and he is currently running with OR straight to final product. So that makes life a lot simpler in a way because he's not experimenting with main buses yet, which is something you can easily grow into. So what I'm going to do is I'm going to cover how I work my way back from the final product to OR, essentially. So I'll show you how I've done that, and then conversely, going from the OR to the final product, how I break everything down, how I segregate everything. There'll be a bit of load balancing in there as well, so it'll get a bit complicated, but I will try and remember to timestamp parts of the video, so that way if you're not sure you can just go back and then pause, just copy what I've done, or you can rewatch that one section over and over and over again until you understand what I'm saying, or just leave a comment and I'll get in touch with you that way. Conversely, if anybody else has any questions, you can join my Discord, which doesn't really have many people in there at the moment. It's kind of dead in a way, but I'm trying to build it up. So if you want to get in touch with me that way, just jump in at me. Job's a good one. I'll get back as soon as I can. So let's just go and get all the maths out of the way for the breakdown of how we get to where we're going to go and how we're going to initially base the production line. Okay, so to explain the way that I do my maths is I'll tend to start with the final product, work my way back through every single ingredient effectively, every single item that's needed to produce that final item, and I take it right the way back to the lowest common denominator, which is the OR input. So by working our way back from the end product, we need reinforced iron plates and rotors to make smart plating. But one machine only makes 2 parts per minute, which isn't what Aaron was looking for. He's looking for 4 per minute. So at that point, obviously you need to double the input of the reinforced iron plates and your rotors.
But if you look at the reinforced iron plate recipe, that produces 5 parts per minute, which is perfect. It's 1 more per minute than what we need. And in order to make that, we need 30 iron plates per minute and 60 screws per minute. And if we look at the rotor recipe, that actually produces the 4 parts per minute that we need to make 4 smart plating per minute. And in order to make the 4 rotors per minute, we need 20 iron rods per minute and 100 screws per minute. So let's get a tally of what we need to be able to make. So for the reinforced iron plates, we will need 30 iron plates per minute and 60 screws per minute. And for the rotors, we'll need 20 iron rods per minute and 100 screws per minute. So we can actually simplify that a bit further by saying we need 30 iron plates per minute, 20 iron rods per minute, and 160 screws per minute. However, because screws are made from iron rods, we could actually translate the screw requirement back into an increased iron rod requirement. So let's have a look at the screw recipe. So as you can see, 10 iron rods per minute translates into 40 screws per minute. So in order to find out our iron rod requirement, we basically take the 160 screws per minute, divide that by 40, and that equals 4. So conversely, we take 10 iron rods per minute, multiply that by 4, and that equals 40 iron rods per minute. So that would then change our total iron rod per minute requirement to 60 iron rods per minute and 30 iron plates. And then from there, we just convert back into the ore, which the iron rods are 1-to-1, so we know we need 60 ore per minute. And the iron plates, on the other hand, so 20 iron plates per minute requires 30 iron ingots per minute, which that's just simple maths. It's basically 1.5. So we need 30 iron plates, which means we need 45 iron ingots per minute in that. So if we add that to the 60 iron ingots per minute we need for the iron rods, which then also makes the screws and whatnot, we need 105 iron ingots per minute. Or also, because it's also a 1-to-1 ratio, we need 105 ore per minute to be able to feed the production line efficiently. So now that we know what we need to be able to fuel the production line from ore to completion, now we need to go right back to the start, and we need to actually be able to provide that. So we'll start from the miner and work forward. So obviously, ideally for this, you would use one pure iron node for this, but you can use any combination of. And the way that I have this set up is I'm using 2 normal nodes merged together to make 120 ore per minute. But that's still too much for the production line. So rather than just wasting the 15 ore per minute that would normally just clog the line up, what we need to do is a little bit of load balancing to be able to get 105 ore per minute going into the production line, and then the other 15 channeling off, which we can merge with other nodes later on for other items. So let's take a look at the load balancer to see exactly how I've been able to get 105 or as close to 105 ore per minute going into the production line as possible. So initially I've got the 120 ore per minute line being split 3 ways, which means it's then being broken into 3 40 ore per minute lines. So as you can see on the first splitter, it'll go straight on into a merger, and then you've got the left output curving around to go back into the merger again. That then creates 80 ore per minute just from those 2 lines. So the line going from the right is 40 ore per minute, which is then split 3 ways, which is 13.3 recurring for each individual line. So we add together, like we did with the first one, 2 of the lines. That effectively makes 27 ore per minute being fed back in. So that combined with the 80 equals around about 107 ore per minute. And on the right hand splitter there, you'll see one line coming down out the bottom and off to the right hand side of the screen. That's where the excess is fed off to be merged into different lines later on. Okay, so as discussed, here is our load balancer, but as you can see from here, we have one miner over there putting out 60 ore per minute, and this one putting out 60 ore per minute. And as you can see, 60 ore per minute. And as you can see, that then goes through the merge, and you can see how it works from here. Let me just clear that off. So you can see you've got your left-hand side and straight on from the first splitter merging together, and then you've got everything else balancing out to combine. And as you can see from the calculator there, we're going between 106 and 107 ore per minute. That's just a mod that I'm using just to show the numbers so you can see how I've got it done. So from there, we're then going into a basic overflow setup, but instead of it coming in that end or this end, we have it going in one point and then splitting out in each direction that's needed. So obviously you have on your smelters, when you come out of there, 30 ore per minute in, and it puts 30 ore per minute out. It's a 1-to-1 ratio. Problem with that is, with 4 of them, that makes, if I show you, this quick way to get this up is to press N, but if we do 30 times 4, that equals 120 ore per minute. We don't need to process that amount. So what we do is we get to the end one. So as you can see here, it's running 100% clock speed. Same with this one, and also this one. So that takes us to 90 ore per minute, because 30, 60, 90. That leaves 100 and, sorry, not 105, it leaves 15, if I can do maths. And then we set 1 to 50% clock speed. You can either click here and type it in, or you can click down here and just type in the target production rate that you want and then press return and it'll change. It's easy for that. So what we do after that is we then start bunching together what we need to produce. So we know from before we have to do iron plates and iron rods. That's the 2 primary things that we do with the ingots. So we have 45 iron plates per minute needing produced. So we'll take a 30 and the 15, merge them together. That gives us 45 ingots per minute. Actually, no, I tell a lie. It's 20 iron plates per minute, I believe. Yes, 20 iron plates. Yep. Oh no, it's 30. Okay, 30 iron plates per minute. I'll get myself confused here. Which needs the 45. So we've got 15 input and then 30 input. So that's where this goes in. Merges together, goes straight into a splitter, which is effectively like an overflow, feeds both machines as it needs to. And then as for the rest of it, the remaining 60 iron ingots, as they come out, they get merged together and then fed straight into an overflow again. This time creating iron rods. So you've got 15 per minute in, 15 per minute out. And that feeds 4 splitters, 4 assemblers, or constructors even, if I can speak. So that is 15, 30, 45, 60 iron rods per minute. Where this differs though is for the output. So we have, let's go up here, we have this end one, because we only need, for later on, you only need 20 iron rods per minute. You have this one going straight to a merger and straight on, and these 2 feed off into the screw line. Now the difference is this one here comes out to a splitter, and because it's 15 iron rods per minute out, we need 5 more to go that way. So we put a splitter in with 3, same as basically what we did back here. You have 5, 5, and 5 going out the splitter. So you have 5 going off to join the 15 to make 20, or 10 to make 20. I really need to learn these things and rehearse them. So it should make 20 eventually once it gets up to speed. And then you have 5 and 5 making 10 to go into this. So on top of 30 there, that makes 40. Should be. That's a little bit low, but that'll build up because this is just all ramping up. This line does take a long time to ramp up. So there we've automatically load balanced our output from the iron rods to go to the next stage. In this case here we have 4 constructors making screws. So as you can see here, 10 rods in, 40 screws out. So that's 10, 20, 30, 40, which is right. And that's giving us all our screws. That's 40, 80, 120, 160 screws per minute, which is what we were looking for. And then what we do again, as per the iron rod output, is we have to manage the output flow. So we know that the rotor needs 100 screws per minute, and the reinforced iron plates only need 60 screws per minute. So we have 40 coming out, so we need 20 going, or 20 more joining the output of this one to go there, and then the rest of them can go that way. But because it's 40 output, we do like we did previously, we just put a splitter in front of one, send 20 out this way to merge with the other one to make 60 screws per minute. The rest all merge together to make the 100 screws per minute, so it's 40, 80, 100 once it gets up to speed again. So ignore this number, this is just a reference for now. It will pick up once the whole production line builds up. So from that point, it's just a simple case of getting an assembler, creating your rotors with its inputs. As you can see, I bypassed the screw line, come in. And I did basically the same thing here with your reinforced iron plates. And that'll quite happily tick along again once everything builds up. The outputs though, I've set them so that they wrap round a little bit to try and save a little bit of space. The reason for that is because it's kind of a reverse overflow in a sense, I suppose, where you've got plates coming in along one side, right to left, and you've got rotors coming in left to right. But in order to do this effectively, what I did is I put the plates along the ground with the splitter, just as you would with a normal overflow. And then here, I've done a conveyor lift with the splitter attached to that. Now, in order to do this, you need to effectively... Actually, I'll show you quickly. If we get the assembler, we'll put that there. And then if we go from about, I think it's here, up 3, obviously you can rotate to set your input, so we can then remove those 2. And then if we just grab that, if you listen, it clicks, or beeps, or whichever, which means it connects. So whatever feeds into the splitter will then go down and into the machine. Just a handy trip. You can even do it the other way around, where the lift goes down through the floor. You can even do it with both. And you can have all your conveyors hidden beneath the floor, so it really tidies everything up. It just depends on what you want to do with it. So that is effectively the whole production line as it stands. You've got your 106, 107 ore coming in per minute, and then as it ramps up, it will eventually populate all these points to get the correct levels that it needs. And it does take a long time to do it, so hopefully you won't be too worried about how long it takes. And as you can see, we're already outputting 3 smart plate per minute. And over time, it does build up to a decent amount. So, yeah. Hopefully that helps a little bit. And there we have it. That is essentially a 4 smart plate per minute production line with how to load balance at various stages throughout. And Aaron, I hope you've really found this helpful. It's purely, this whole video is spawned purely because of your question, and I'm so glad you asked it. Thank you very much for that. It's given me no end of fun trying to figure this out. And hopefully the techniques that I've used and the way that I go back from final production to get the minimum or the maximum number of base quantities of items that I need, and then rework forward to try and formulate everything again. Hopefully that's given you an insight into how I work it out, so then you can apply that same concept to different production lines later on. Let's say heavy modular frames, and you can even try it with manufacturers later on when you get to the really big stuff like computers and or supercomputers and stuff like that. But yeah, if you need me, just get in touch, leave comments in the video. You can join the Discord and at me on there, and I'll get either relatively quickly, so that's always good. It's the same for anyone else. If you want to comment, subscribe if you haven't yet, because at the moment only about 5% of my viewer base is currently subscribed, and it'd be great to see that a lot higher than it is. And if you have any questions, just comment on a video or at me in Discord and ask away, and I'll quite happily go and do the same as this. But with all that said, I hope you've all enjoyed the video, and with that, I will see you in the next one.